injection project, which is here, right here. Okay. So the first thing is to learn something about SQL. And by the way, these horizontal lines indicate sections. I'm running several databases on my SQL server, so all these sections are separate. So first, you just have to learn this language called SQL. Now, we just did, in the previous ED 102, we did bash command injection, where if you know bash command line, you can inject commands. And this is the same thing, except you have to inject commands in this language called SQL. So you have to learn what it is. So here's a query form of the type you would not let an end user have. You'd only let the administrator have this. And we can try some of these commands so you see what SQL commands do. Show databases lists the databases available on the server, and there's two. One called widgets, which contains company data. That's a name made up by the company. And this is the one automatically generated by the MySQL software, information schema. Now you're going to see that you can get anything you want from SQL, but you have to know the name of the data you're trying to get. And that turns out to be easy because there's an automatically generated file that always has the same name, and you can find all the information you need about names in here. So this is the structure of the database, and this is the contents of the database. This will contain employee data like social security numbers and passwords and things like that. So that's show databases. Now you can also show tables. And it's going to show you the tables in the current database, and the current database is widgets. This widgets database only contains one table called employees. And here's the thing to understand. There are four objects in data. There are databases contain tables, and the tables contain rows and columns. That's it. So there's a table called employees. So the next thing I'd like to do is know more about that, but before that, let's learn how to do some more selects here. Those are show commands. Now here's a select command. You can select just a number, like 1, and then you'll get an answer that's 1. 1 result, 1. Okay. You can also select an alphabetical thing, like peanut, and this will just be like the echo command in Linux. It will now give you peanut. So this may seem useless, but it'll become more useful later. And you can manipulate strings. I can concatenate two words together, peanut and butter. So if I can only have one column of data, but I want two pieces of data in there, I can concatenate them together, and now it will appear as just one object, peanut butter. This is going to be important later. And you can also select substrings. So if I do a substring of peanut, 2, that's going to take the word peanut and start at the second character and give me 2 characters. So it's going to be EA, because it starts counting at 1. So that's the second character, and it gives me 2 characters. This is how you pick an individual character out, and the reason you do that, we'll see later. If I do this, it's going to check to see if the the second letter in peanut equals E. This will be the second letter and only one letter, and does that equal E? And it's 1, which is true, because it does equal E. If I made it a different letter, like A, then it would give me 0, which is false. So you can have a true or false statement in this equal sign, and it will evaluate it to tell you if it's true or false. Now, I found that there was a table called employees. So the simplest way to get all the data from employees is select star from employees. This would be nice. This will give you all the data, so you see it has ID numbers, names, and social security numbers for my employees. The problem is you can almost never execute a command like this unless you're the administrator. What you will be able to do, though, is one like this. Select ID from employees. You can select one field from the employees table, and then you get the ID. But if you wanted like the SSN, then you could do that and get the SSN, but if you can't connect the SSN to the ID, that could be annoying. So if you only can have one column, you could, of course, do concat. Concat of SSN and say name. And then you'd get useful information. Now you have SSNs and names. And if you want to get fancy, by the way, you could even put like a space in here. And that would make it even easier to read. To get 2 things. All right. So now you can select for just one employee. if you add a where clause. This will select name and ID from employees where ID equals 1. Now I get only one user's information, and this is essentially what's going on whenever you view your email on Gmail or your profile on Facebook. It's selecting the data from the database for your account and nobody else's account. Let me just check on the Twitch for comments. Nothing new. All right. So now you can concat them, and here is a more complicated select command that's more interesting. Okay, this is going to get name and ID from employees where ID equals 1 or cat equals dog or 2 equals 2. Now, if you know your Boolean, this condition is only going to be true for one user. This condition is always going to be false, and this condition is always going to be true. And if you have true or something, the result is true, so this will give you all the data in the database. This combined Boolean condition is always true. And all right. And now we can insert data in. I'm not going to do that. That doesn't really matter much. But now let's learn more about this information schema tables. If you go into the information schema and you get a list of all the tables, maybe dot tables, here's a list of all the tables, and all the ones in capital letters, of which there are hundreds, are all the automatically generated ones that MySQL uses just to set up the database. And way down at the bottom, typically in small letters or any other ones, nothing here you're going to see. These are all, because I just looked in information schema directly, all I'm seeing are these automatically generated tables. They're not terribly interesting. Now I could select table names from information schema tables. And now I get just the table names, and again, it's just a long list of capital tables. And here, I got the name of the employees. It knows in information schema tables that there is something called employees, and that's actually got company data. All the rest of these just contain automatically generated data about the database. And now I can select columns from information schema columns. I can get a name of all the columns in the database. In both databases, I think, in fact, all the capital ones are the automatically generated column names, and way down at the bottom is going to be the columns for the company in lowercase letter, ID, name, and SSN. Those are the columns in the employees table. And so I could get more specifically that if I get column names from information schema columns where table name equals employees. Now I'll get exactly the columns for the one table I want. So there you go. Now I get ID, name, and SSN, and this is really important. All right. So that's a summary of the basic things you can do with SQL, and now we're going to do injections. There's a couple flags to find just by using these commands. And now if you go to the next section, I'm going to reset the server here. All right, and now the problem is you don't get this kind of field to work with as a user. It would never let you have an administrative field where you can just type in any SQL command you want. That's only for the administrator. As a user, you're only supposed to be able to see your own data. So they might give you a search field to see if someone else is there. So if I search for Bill Gates, this is what an end user would have. I can submit, and it will tell me it found Bill Gates. Okay, that's fine. If I misspell a name, like Bill Gates, now it's not found, and I get no result. But if I put in Tip O'Neill, now I get a syntax error. This is the clue that you have SQL injection. I should not be able to break the syntax of the command. And here I show you the query, and you can see why. Select name from employees where name equals Tip O'Neill. The problem is these apostrophes were put there by the developer, and this apostrophe was put there by the user. And since you created a line of text which is then parsed, it parsed it looking for a name Tip O, and then it expected another SQL command here, like maybe or and Neil is not a valid command. That's why it failed. So this means data I put in is misinterpreted as a command put there by the developer. That's command injection. It's SQL injection. So this is a denial of service attack where you caused the error, and now I want to turn it into a controlled crash. So let's start with Sam. There's no Sam in the database, so I get no answer. But if I put this Sam apostrophe or 1 = 1 pound, Now I'm going to get all the data in the database, all the names, and the reason is because, look at what happens. The condition is where name equals Sam or 1 equals 1, and that pound is a comment character, so it eats up the extra apostrophe at the end. So this is now a valid condition, and it's always true. The name is never Sam, but 1 always equals 1. So now this condition is always true, so I get all the names. That's the simplest kind of SQL injection. I've tricked it into dumping out multiple results when it was really only supposed to show me one result. But you can do a lot more. If you do this, this is how you add a second whole select command. See, when I type in a name, it's going to do a select based on that name, and I can't change that part. But if the union command lets you add a second select, so what happens here is the developer wrote this code, and I can't change any of that. But I can change this code up to the apostrophe. And now, even though I can't stop the developer's code that only shows me a name, I can put a union and select something else. And as long as it has the same number of columns and a compatible data type, it will add it. So it runs the first query, which looks for a person named Sam, and there's none, so there's no result. And then it runs the second select and finds a 1 and puts a 1 there. So what's happened is, I have now turned this box into that box. Now I can execute an arbitrary select command even though the developer only intended. So if I want to learn more, like I want to learn the name of all the tables in the database, I can take one of these selects and I can put it here. And now I'll get all the tables in the database. I can do all the things. Here I find there's a table called employees and another table called passwords. This is the point. You can now do all these things you did up here, even though you only have a name search field. So that's the point. And so you'll be able to find the names of the tables, the names of the columns, and dump out the data in the tables. You'll be able to find social security number, passwords. And the pros, by the way, never do it by hand like this. They mostly use SQL map. So if you have a Kali machine or a Linux machine, you can use SQL map. And I have some instructions here from an old project I wrote showing you how you can use those to help you learn how to use SQL map. There's various SQL map challenges here if you want to play with that. And by the way, notice most of this is extra credit. Just 30 points is all I expect, but there's 155 points of extra credit here if you do all the extra SQL commands. And the last part, which is really fun, is blind SQL. Again, I'll reset the server. All right, and now, so here's a list I can search for names. So again, if I do Bill Gates, it finds Bill Gates. Okay, so this looks just like the previous one, but it isn't. If I put in X, there's nobody named X, so it doesn't find anybody. So again, it looks like before. But if I do a SQL injection, the simplest one is just put in a single apostrophe. I get an error in the SQL syntax, so that shows the vulnerability. Now, if I want to do something more productive, I'll do this, X or A equals A. And this is carefully missing an apostrophe at the end, so the apostrophes the developer puts there will make a valid statement. So now, name equals X or A equals A. So this condition is always true. The name is never equal to X, but A always equals A. So I expect to see all the names, but I don't see any names at all. That's why this is called blind SQL injection. My command is being executed, but it doesn't show me the answer. The way the developer wrote this script is if it finds you, it repeats the name you put in, which was this. It doesn't show you any data from the database. So you can't see the output. So at first, this seems useless, but it's not, because you can do this. You can do or B equals A. And now you'll get no answer. So what you can do is you can put any condition here that is either true or false, and you can tell if it's true or false. If it's true, you'll get a result. If it's false, you won't get a result. So now I can try to determine things like if I want to know the name of the database, I can find the length of the database here. This one will show me. So this is going to look for a name of X or a length of database equals 1. I get no result, so this condition is false. The length of the database does not equal 1. Therefore, I guess it must be greater than 1. And that's true. So now I can narrow it down. I can say, is it greater than 4? and it is greater than 4, and so on. So I can get the name of something. You can even pump out passwords and such. Here's an example of how you're going to get a password. We're going to get the name of a user. You get used to these really long injections. So this is going to union select name from employees where name equals Bill Gates and substring name11 equals B. So this is going to see if the first letter there is B, which it is. So it found something, so that condition was true. If it was A, the first letter of Bill Gates' name is not A, so I don't get a result. So you can find things here. You can get the link to the database names. You can get Bill Gates' social security number. Let's see if there is an SSN in here. And, I got it. That condition is not true. So let me change the condition to B. All right. And now there must be a field called SSN, or it would have told me no SSN field. So it is, it's showing name there. I'm able to do a select SSN from employees where name equals Bill Gates. Okay, now I can ask about the SSN. I can now say substring SSN 11, does that equal 1? And it does. So the first digit of his social security number is 1. And in case I'm not sure that's true, I can try 2. And I don't get an answer. So I was able to guess the first digit, and you can continue to guess digits by digit to get there. So this is basically like the 20 questions game. It's pretty interesting, an interesting logic puzzle, and you'll be able to pump out passwords and social security numbers and everything else by doing a series of questions. And if you know the game 20 questions, the basic idea is that 20 true or false questions is enough to find anything. It's enough to get you down to 1 out of a million. So that's anyway, that's what you're playing here. And so I wanted to show you that. This is SQL injection in various kinds, and it's a very important attack worth playing with. So I'm going to stop this recording.